Hi everyone, this video is on the challenge question of exercise 12F. The line L is a tangent to the curve with equation y is equal to 4x plus 1, and L cuts the y-axis at 0 minus 8. And it has a positive gradient. Find the equation of L in the form y is equal to mx plus c. Okay, so in this case we have a curve, and then we also have a line that is a tangent to the curve. And that tangent at the same time cuts the y-axis at the point 0 minus 8. And we want to find the equation of L. So first of all, again, the procedure is the same when we have questions like this. We first need to find a gradient. And in this case, if we want to find a gradient, we first find the derivative. So dy by dx is equal to 8x. So yeah, that's the derivative. Okay. But we have always said that if we want to find a gradient, we also need to know the point that the tangent passes through, so we can substitute the x coordinate into the derivative equation. But in this case, we don't have that, so we are not given that point. But one thing we can do instead is simply using 8x as our gradient for now. So then we can later on find the equation of the line. So what I mean exactly is that we know that the equation that helps us to find the equation of a straight line is y minus y0 is equal to m times x minus x0. So y0 and x0 are just the coordinates of a point that the tangent line passes through. And in this case, we are given a point. So this is the point that the tangent line passes through. But remember, this is not the point that is also on the curve, because if the point is on the curve and the tangent line at the same time, then we can use that point to find the gradient. But this is not on the curve, so we can't use this to find the gradient. But what we can do instead is that we can use this line which is on the tangent, this point which is on the tangent line, and also this 8x as a general form for the gradient, and then substitute them into the equation and get the equation of the tangent, but without having the value of the gradient for now. So this is going to be equal to y minus basically y plus 8 is equal to m. So for the gradient we said it's 8x for now, then x minus 0. So we can then rearrange this to have 8x squared minus 8. So this is the equation of the tangent, but again, without having the exact value of the gradient. And we should also remember that this tangent has a point of intersection with the curve, so we can easily find the point of intersection, and by having the point of intersection, we can find the gradient. So the tangent meets the curve, and as a result of that, this equation holds. So the equation basically of the curve is equal to the equation of the tangent. So we can use this to find a point of intersection. And by having this, then let's find the point of intersection. So we are going to have 4x squared is equal to 9, and then x squared is 9 over 4, which means x is plus or minus 3 over 2. So these are the two x coordinates for the point of the intersection. But remember that here we should be very careful in terms of choosing, because there is only one point of intersection, so only one of these is correct, and it can be used for the rest of the question. And then this comes back to here, when the question says that the line has a positive gradient. So remember, these are the x coordinates of the point of intersection. So if the x coordinate is positive, then remember that the derivative is 8x. So 8 times a positive number is going to give us a positive gradient. But for the negative x coordinate, this will obviously give us a negative gradient. So therefore, in this question, the point of intersection is 3 over 2, because this gives us a positive gradient. So this is the point of intersection. Okay, now that we have the point of intersection, then we can then go back and find the gradient of the tangent. So we just substitute into 8x. So when x is equal to 3/2, then divide by the x is equal to 8 times 3/2, and that gives us 12. So in this case, 12 is the gradient of the tangent, and we can use this to basically find the equation of the tangent. And that's very simple, right? Because we already know the y-intercept, so, and also the gradient. We can then easily use the form y is equal to mx plus c, where m is equal to 12 and c is minus 8. So this is the equation of the tangent in the given form. Again, just remember that in many questions they ask you to give your answer in a specific form, and that usually has more it just depends on the question. Sometimes you have a mark for that. Yeah. Okay, so that's it for this video, and thank you for watching.